This is a video part 1 of an ornamental turning lathe project in which I'll demonstrate how to create an STL file, a design, and G-code of a simple conical box. I'll be using Grblgru, COrnLathe, and Mach 3. This is a simple box that I've turned. It has a slight slope on it that's created out of birch. Using Grblgru, I can activate the probe function. I have a active probe that I can use. I've adjusted the width a little wider so you can actually see it on the screen. I set the speeds to slow enough that I'm not worried about a crash of my probe. I set the pullback at 5 millimeters. In this case, if it was a steeper sided bowl, it should be a bigger value, like 10 or 15 millimeters, so you won't crash the tip as it's going along the work. I'll be sampling every 10 millimeters over a 90 millimeter distance. Clicking the start button will initiate this action. What you see on the simulator screen is what's happening in real life, and I'll show that later. As Grblgru samples each point, it registers a little blue dot. When it's finished, it'll retract slightly, form the STL, and go back to the beginning. It's very important to enter the maximum diameter of the piece that you're sampling. The radius goes in the upper box there, and the set model Z position is very important to get an accurate model. After the STL is created, you can save the scan points, as I've done here. And you can save it as an XML file, which I use in COrnLathe. Holding the control key and left clicking, you can outline the box, and if you hold the same control key and right click, you get a dialog box in which you can save the STL, which I've done already. The other way you can do that is to go under File and save that STL. That's the end of the probe routine. This takes no time at all. I like to delete that result and then re-import the STL so I can see if it is what I thought it was. And there it is there, just as it was in blue. This is the model that I would use to design on. So in real life, this is what happens. I position the probe at the base of the object. It's sampling every 10 millimeters. And as you can see, even with these slow speeds, this process does not take very long at all. The maximum diameter is right at the very end there, and that's the one I have to enter in the radius box. Now I've replaced the usual round tip of my probe with a PCB board standoff and a sewing machine needle that I've broken off to make it sharp. Here we are in COrnLathe. I've already imported the file right here. By double clicking on it, I can bring it up. Right clicking the mouse button, I can drag down the thing. and we can have a look at it in the preview window. Right-clicking, drag it down. You see it's illuminated on the inside, so I want it on the outside because that's where I'm working. And I double check that that's the same in the bottom left, right-hand corner there. I adjust the cutter to an ideal shape because this renders much more quickly. It's best to enter the values you want in this screen before you start designing. In this case, I want a horizontal cutting frame, HCF, and I double checked the radius of my cutter, which in this case is 1/2 inch. I can start designing by dragging pieces onto here. I want to start the design at the very top, the very right-hand side of that box. I can adjust the width of the wall of the box, that's the purple line, so we'll put it up to 0.2 inches. This line is the axis of the cutter, that's the outside of the box. When I drag over a design point there, you can see I put it right on the tip. This is the radius of the cutter, and you can see the outer and inner cuts that cutter's going to do when it rocks back and forth. Going to the data screen, you can pull down that cut and see it's the default, which is sine 8. I can go to that sine 8 and convert it to 24, hit enter, and you can see all 24 waves have been placed on there. Now I know that I want the depth of cut to be a little bit bigger or a little deeper, so I'll go from 0.05 to 0.07. Now this is a rocking action. I could have pump or something else, but I want rock in this example. So that's the kind of marks that the cutter will make in the wood. So I'll drag another point just below that one, and I'm just eyeballing this for now. It is possible to put them exactly distances apart, but I've done this one a few times. I can also just double click on that axis line and I'll get another point placed. I don't have to drag anything over. So all those points are in the same phase, and I want them slightly out of phases, starting with the middle one. So the pH, the phase, can be found here. I'll change it to 180, and that'll put it half out of phase with the first and the third ones, and that's the kind of pattern that I want. So I can double click on that axis line to add some more points, and in the case of this pattern I can click on the outer radius of ones I've already done. If I turn off the render button, this all goes a lot quicker. So I can double click where I want my points going down the side there. All of the values of a last point are reproduced in the new point. Cut depth and phase. This is the last one I want right at the bottom. They're all lined up there. The spacing is pretty good. So I'll go to my Data Navigator page and open up each of these cut points. You can change many of the values on this, as shown in my COrnLathe Basics video posted earlier. So I want a value of 180, so I need to select all the odd numbered points. Because the first one is 180 and the other ones are 0, when I pull this up it'll say different values, but if I click that and put 180, it'll change it for all of them. Go back there, and I usually double check to make sure I didn't skip one or get the wrong one. Using this screen, you could adjust each of the positions of those cuts as well. So time to see how well I did. So I'll render it. And that looks pretty good. If I turn off the lines, the pattern is clearer. But that's the kind of netting pattern that I wanted. I checked to see if the spacing is about what I wanted. The next step is to create the Gcode for this, which is quite easy. I usually put these sliders up to maximum so it goes a little faster. I can adjust the speed in my Gcode center. And to create the Gcode, you just click the Gcode button. And there it is showing up in my favorites file. I can find that on the computer, which I'll do now. Go to the right file, and there it is. Gcode files can be edited in simple text editors like Notepad. I prefer using Notepad++. So here it is in Notepad++, and you can see every line has a G93. And this is the function to coordinate the actions. The F values are speeds calculated for each line. The problem is you have X, Z, and C values here. Most C values are not handled by ordinary hobby type control cards. But it's very easy to change this C value into an A. So you just do a replace all. Usually takes about 30 seconds. This is quite a long program because there's many cuts and many passes. It'll also change the text at the top. So there's all the A values. I like to save this under a separate name. Usually I say C to A so I know what I've done. There's my original file and there's the new file. I can open that up in Notepad++ just to double check. And there's my A values. That's all I need to know. Now I can go to a sender. In this case I'll use Mach 3. I've created my ornamental lathe profile. You have to hit the reset button so you can do anything. So I'll load the Gcode program that I've just created. Mach 3 will take it and process it, and it automatically changes to a inch mode. And this first line will show you exactly what you need to position your cutter. I need those values there. So what I do is I'll move the cutter over in real life. You won't be able to see it, but I'm just bringing it over closer to that top right edge on my simple box, as I've shown before. I have to get out of my chair and just check and see if the tip of the cutter is there yet. That's why there's pauses. A little bit more. And then the X I had to adjust slightly as well. So once the tip of the cutter is positioned parallel right at the top of that work where I want it, I can enter the value from the first line there. I didn't hit the return key, so I have to do it again. 1.81. And then for the Z value, I need 3.5. Once that's hit, I just double check to make sure I got the right value. Right there, that's all pretty good. Now all I have to do is hit the start button, and the work will start cutting, and we'll see that in part 2. Thank you for watching.